Hello, good morning, and welcome from wherever you are joining us today to this webinar. Our today's topic is about system extension. So what if we have an existing SnapInverter or an existing Gen24 product and we want to build a newer, bigger system on top of it? This is our topic for today. We have prepared a few scenarios that you might like to encounter and some solutions for that. First of all, let me introduce the team for today. We have David from the trainings team who is doing the chat today. So if you have any questions, send it through. David will try to answer as good and as quick as possible. And my name is Chris. I'm also from Team Trainings and will guide you through the next few minutes. Now, on the agenda, we have today some general informations that you need to know when it comes to system extension, system expansion, then some different scenarios. So, for example, 2 SnapInverters, a Snappy and a Gen24, and a Gen24 SnapInverter Wattpilot coverage, and of course as well some backup power solutions. What do we do there when we have to extend the system? Last but not least, in these scenarios, I want to quickly go through a ripple control signal option, which might be used still by some grid suppliers. In Austria, it's not so common anymore, but there might be a use case for you out there. Then we go to some very important settings that you need to do on the web interface of the inverter in order to utilize all of that. And last but not least, some settings in SolarWeb. How can we combine all the production power into one system? All right, so let's get started with the first topic and some general information. I don't want to go into too much detail when it comes to inverter power and sizes, but we need to know that there is a Gen24 and a Gen24 Plus. So we are currently in the launch operation to have an addition to the Gen24 Plus family. The Gen24 Plus would be the battery compatible one, and the Gen24 then would be a preparation for future improvements. So if you don't want to install a battery right now, you can order yourself or build in yourself a Gen24 inverter. It has all the connections for a future battery connection, but they're not activated yet. So it's a cheaper product that you can buy right now, and then you can upgrade it later on down the road. Now, on the SnapInverter side, we only need to know that there are different types, different phases. For example, we have the Simo inverter for 3-phase and the Primo for single phase. And the most important thing for our webinar today is that there is a light version available, which does not have a Data Manager 2.0 card implemented. So it's a standard SnapInverter, which feeds into the grid. It does all these things, but it is not able to connect to the internet and supply data to SolarWeb. So the standard version, and then there is the light version. That's very important for our webinar today to understand these things. Now you can retrofit a light version with a data manager also later on and make it online able. All right, so the basic setup for our system that we talk about today is always an inverter with a Fronius smart meter. The reason for that is it is the future-proof version for all the components that you might need to add later on. Because with the smart meter at the fit-in point and a Gen24 or a SnapInverter with the inbuilt data manager card gives you the possibility to connect to the internet, to have a cool system visualization online on SolarWeb. We are able to add a ohmpilot, a wattpilot, a feed-in limitation, and if it's a Gen24 Plus, we can also right away add a battery to it. This is all possible with the standard setting. We can see where the Fronius smart meter sits. right at the feed-in point. We see the Modbus communication, the cable protection for the inverter, and also the RCD for the loads. Okay, and based on this on this schematic, we now take a look into some system extensions. Let's say we want to add another SnapInverter to an existing SnapInverter system, for example. And this new system that we want to add can be a light version of the SnapInverter. The reason for that is very simple, because on the SnapInverter we have a so-called solar net ring possibility. It's an interconnection possibility between the SnapInverter series. This is with the green line visualized here, and therefore nothing else is needed. We simply add the AC side and connect it in parallel and have one data manager on the existing SnapInverter, as we can read down below, and we have a total production view on SolarWeb, because the value of the light version is transferred to the data manager of the first one. They are added up and sent to SolarWeb. So we can stick with one smart meter and only need to add the solar net cable, basically. So this would be probably one of the easiest way to extend your system, of course. Another way would be if you have an existing GEN24 plus inverter, let's say with a battery already connected to it, and now you want to add another GEN24 product. This is also a possibility, no problem at all. And because the data unit, the pilot card it is called, is already built in, we can also add the two systems online. So we have two data sources and they can be interconnected on SolarWeb and give us a total production value. So it's the same procedure, just parallel connection on the AC side, and the communication is done via the internet then. So no direct cabling possible or necessary between the two devices. They're simply added up on SolarWeb. Now, let's say we have now a system with a GEN and a SnapInverter. As you can imagine, it is also possible to interconnect those two on SolarWeb if the SnapInverter has a data manager card implemented. And there could be some scenarios now where in some regions, some countries, the grid supplier says you have to do a feed-in limitation because the transformator is at its limit, the cable is at its limit, whatever it is. You have to limit the value of your feed-in to 50%, for example. Now, we need to understand that this can only be done by one of these inverters, because right now there is no interconnection with a cable between the SnapInverter and the GEN24 product. We're working on a solution which should come next year, but right now only one of these inverters can handle this, and it's this one with the smart meter connected to it. Now, in this scenario, we have the battery, so we need the primary smart meter on the GEN24 in order to do its thing. And here we need to set also the feed-in limitation. Let's say we have 50% feed-in power limitation, and we have for both of these inverters a 10 kilowatt. Now, in this scenario, the GEN24 can handle this limitation, because 50% of the 20 kilowatt in total would be 10 kilowatt, and it can be done by the GEN24. So this is one solution we could do. What if we now have a system where the SnapInverter is a 20 kilowatt device, or if it's an Echo inverter with 27 kilowatt even, and we still have a 50% feed-in limitation? Now, in this scenario, the GEN24 is too small in order to achieve this rule. In this scenario, the feed-in limitation has to be done by the SnapInverter, by the bigger one. But we know already that in order to achieve this, we need a smart meter at the feed-in point connected to it. Now we can do the following. We have a second primary smart meter in front of it. So it's a serial connection basically. One is connected to the GEN because we need it for the battery charging and discharging. And the other one is connected to the SnapInverter in order to fulfill the feed-in limitation. Now, in order to have it ready for the SnapInverter, we could do it like this. The only downside for this scenario is that both of these inverters cannot be interconnected on SolarWeb because only one primary smart meter is allowed per system. So this prevents us from interconnecting them. So we would have two separate systems online on SolarWeb, but then we would have these feed-in limitations fulfilled. There would be a way around this with adding a secondary smart meter in the production line of the SnapInverter. So like we can see here, we add the secondary smart meter, we connect it to the GEN24 inverter, and then we have one SolarWeb system where all of the production value can be seen. On the one hand side, the one of the GEN24, we can see the feed-in value of the smart meter, and we can see the production of the SnapInverter with the secondary smart meter. Now this would be one solution where we have to use the SnapInverter in order to have the feed-in limitation ready. Okay, let's step ahead and say we have another system without any feed-in limitation, but now with the system extension, we also have a Wattpilot for charging our electric vehicle. This is also, of course, no problem. It's simply connected AC side here, and we can utilize now both of the production values in order to charge our vehicle. Because on the Wattpilot, we can add the value of the, so we can add the component to an inverter, and this inverter tells the Wattpilot how much surplus energy we do have available for charging. And because the smart meter measures both the GEN24 and the SnapInverter production, we have the total value able to communicate to the Wattpilot. So in this way, we can utilize the whole system, the total amount, in order to tell it when we can start the charging process. The same goes, by the way, as well for the battery, for the stationary. We can tell the GEN24 inverter if we have another inverter installed, for example, the SnapInverter, and how much AC power it produces. And then it utilizes this additional power as well for charging via AC. So this is possible as well. I'll show you later on how you can do the settings. Now, last but not least, there would be this scenario with a backup switch. Could be looking like this. We have the backup switch right here, and the SnapInverter as well as the GEN24 inverter are connected here now to the loads. And of course, the GEN24 would start up the production also during a blackout when the backup switch is disconnecting from grid and supply the loads. The reason why we put the Wattpilot out of the backup scenario is it is not a mandatory load to have, or an emergency load, let's say. It is really important to have light and the basic function of the house up and running, but not necessary to have the big loads as well. This is why we put it outside. Now, one thing we need to understand, the SnapInverter can be connected like this, but it will not run in a blackout scenario. The reason being that the GEN24 fires up in blackout with a 53 Hertz signal. And with this higher frequency, that all the other inverters, doesn't matter if it's Fronius or another brand, is not allowed to reconnect. And it is a protection system in this case. So we build up 53 Hertz so no one can reconnect to our system and fill our battery and basically would destroy the system. Because imagine if we have no grid, the battery is full, and this secondary SnapInverter recognizes this as grid and feeds in all its power. we don't have anywhere to go. And as we currently not have any option to interconnect the two inverters and control it, we have to shut it down with the higher frequency. This is the reason why we stick with this solution. All right, so that's it, or that's enough for now, let's say, for these different scenarios, these different settings. Let's head on to another important step, the ripple control signal. So if you ever encounter it, if the grid supplier says you have to use this receiver unit, then it would look like this. You get the receiver unit, which gets the ripple control signal, and it is connected then to our digital in and outputs on SnapInverter or Gen24 products. Both of them are able to do it like that. So we can see here a screenshot for the Gen24. This is the middle orange plug, the bigger orange plug, and we see here digital IOs. And it's very simple. As soon as the signal hits, we have, for example, the active power limitation to 100%. As soon as the second one is activated, we go down to 60%, then to 30, and then to 0, for example. And we can do an active power limitation in percent and or a power factor limitation even. And the cool thing for a ripple control signal is, as we have just heard, we can do multiple systems with it. So if you have multiple Gen and Snap inverters in one system, you can just split the signal up and connect multiple ones to it. And all are then controlled with this ripple control. So the connection examples, of course, have to be done by the statements of the grid supply then. In our operating instruction, we also have some examples. You can even download some predefined settings if you want. And it would look like this then when you do the activation. You go to the web interface of the inverter. You go to safety and grid regulations, which requires you to enter a technician password. And then we go to IO power management, where we can see the overview of the rules. And then we activate one by one as we have to. As mentioned, we also have a pre-configured file for relay operation that can be downloaded and imported from the manual. So right down here below, we see the import button. And if we hit it, we can upload a pre-configured file, for example. And it could look like this. Rule number 1 says that if input number 8 is active, if we have 12 volts on there, we reduce the active power to 100%. The next one would be then to 60, 30, and 0%. This is just one example right now. There would be also some solutions with just 2 signals or just 3 signals, whatever is necessary then. Okay, so that's it for the ripple control signal. Let's head on to some very important settings for the correct monitoring. And we start with the Snap inverter and its solar nettering. We've heard it's only available for the Snappies. It's a RS422 signal in a ring-shaped matter, basically, and it's done via an in and out communication setup. So we can see here from out of the first inverter to in of the second one, we just cable through. And please don't forget, it's a ring topology, so we need to set the termination plugs at both ends, at the beginning and at the end. We can see it here. It's a simple termination plug. Without it, it won't work. Very important. And you can use standard Ethernet or patch cables for this. So category 5 is sufficient enough. You can stick with these. We also have heard that one data manager is also enough for these systems. So in a setting like this with 4 Snappies, only one of them needs to have a data manager. All the other ones can be a light version. And then all these 4 data sources or values are collected by this one data manager, and this one sends out the data to SolarWeb. Now, some important settings I've on the right-hand side here. We've heard termination plugs need to be set on both ends. We need to address all inverters with an inverter number on its display. So we start with number 1, where we have the data manager installed. So this one would be number 1, set it on the display, and then ascending, we go to inverter number 2, 3, and upwards. And in theory, we could do 100 inverters for one data manager. So 99 light versions can be connected to one with data manager. Of course, this is a theoretical thing. It is possible still, but I wouldn't recommend you to do this. I would say go with groups of 30 or 40 inverters per data manager to have more or less fail-safe. If something goes wrong, you still have other systems, other data managers up and running. And if you have multiple SnapInverters with inbuilt data managers that you want to interconnect, this is also possible, but please make sure that all are set to a slave position but one. Only one master is allowed in a system. It's a small switch on the data manager, and please set all of them to slave but one. Yeah, then of course the question is raised, how do I bring the inverters online? How do I add them into one system? Now, there is 2 ways to do that. The first one we can see here, we go to the web interface of the inverter. This would be a scenario for a GEN24. We have the access point, we open it, we reconnect with it, and open then the browser or our tool, the Solar Start tool, and have then this option visible with these 3 steps: network, product, and SolarWeb. And in order to reconnect to SolarWeb, we firstly need to do the network settings. So we need to bring it online. And then when we go to SolarWeb, we have a few options. And one of them is called add the product to an existing PV system. Now, if this inverter here would be the new addition, we simply hit add product to existing PV system. We add it to the one we already have online, and that's it. Both of them are then summed up, the value is summed up, and we have one visual. So this also goes for the SnapInverter, of course. The steps might look a little bit different, but we still connect to the inverter via the display. We then go to the internet connection and set it up. And as soon as we go to the SolarWeb registration, we have the 3 same buttons with one calling add product to existing PV system. And then we simply add them online. Now, the second option would be to have the internet connection ready. This product is already connected to the internet, but SolarWeb isn't finished. Then we can go to the existing SolarWeb system that I have online, go to settings and components, and simply add a new device. So right here on the left-hand corner, we see new device. I can hit the add button, and it asks me then, okay, what is it? Is it a data manager, a GEN24, or a Wattpilot? Important thing here, also a Wattpilot needs to be added here under components in order to visualize it correctly with its own color. And yeah, I simply select the one I want, for example, the data manager from my SnapInverter. I add the data log ID, or if it's a Gen, the serial number and the V code. Both of them can be found on the side of the inverter, on the nameplate. And I hit the add button, and yeah, same thing happens. We add the 2 systems online together, have one production. Now, earlier we talked about the usage of other generators in a system. So let's say we have an GEN24 with a battery, and also we have a SnapInverter, and we want to utilize this AC power of the SnapInverter. This is very easy. When you go to components and add the battery, there is this little button calling allow battery charging from other generators in the home network. And if you enable it, a window pops up on the right-hand side asking for the maximum charging power from AC. Now this would be the AC power from the SnapInverter in this case. Let's say it's a 5 kilowatt SnapI. And with this value typed in, the GEN24 Plus knows then, okay, I can count with additional power, maximum 5 kilowatts, and I utilize it as well for charging the battery. By the way, this also is possible with hydroelectric power plants, with wind turbines, or any other third-party AC source, of course. All right, one more thing would be the feed-in limitation. We have heard about the different settings where we can select it on the GEN or on the SnapInverter, and we already know where we have to set it right now. And yeah, this is just one example how it would look like on the interface of the GEN24 inverter. We can limit the entire system, just select the mode here, and then we type in the total power of our system. So if we type in here 10 kilowatt, this means we have a 5 kilowatt SnapI and a 5 kilowatt GEN24, for example. So this would be the total power. Then we select export limiting control. In the brackets, we can read soft limit, meaning it's a dynamically controlled power reduction. And here we enter the maximum grid feed-in power. For example, 5 kilowatts is maximum allowed back to the grid. This is possible by one of these inverters, and we hit next and are safe. So this would be one option to do it in a GEN24 web interface. And we have heard already, and please remember that only the master inverter with the smart meter primary connected to it is able to do these limitations. So we need to figure out which of these inverter is able to do the feed-in limitation that we require to fulfill. All right, so last but not least, let me quickly talk about Solar Web and how does it look now with additional systems in one SolarWeb setting. Now, we remember this. On the left-hand side, we can see the bubble chart. On the right-hand side would be a daily production curve. And on this bubble chart, if I have now a SnapI and a GEN interconnected on SolarWeb, we would see here on the left bubble a total PV power. So this would be a summed up version. We would see the total consumption, because one primary smart meter gives the data to the master, to the GEN24 in this case. We see the total grid power and also the battery charging with both inverters, if we have enabled the charging of the SnapI as well. So this is how it would look like. And on the right-hand side, this would be the daily production curve, which also shows us both systems, SnapI and GEN24. Now, last but not least, I have put in some errors that you could encounter, and I also want to share some solutions, how you can resolve this problem. So for example, on this bubble chart, we can clearly see something is wrong. We produce 3.7 kilowatts and feed in 5.5 kilowatt back into the grid. Clearly something is wrong in this case. And in our scenario, we have a second inverter built in, but without a data manager. So we are not able to interconnect it on SolarWeb. There would be two solutions actually. We can either add a secondary smart meter in the production path and add it to the GEN24 inverter, or we add a data source, the Data Manager 2.0, and add it to SolarWeb. Both options would result in the same thing. We resolve this weird looking bubble chart in SolarWeb. Second problem, we have a consumption which follows the production curve. The solution in this case here would be the smart meter is connected wrong. It is not in the feed-in point, it is in a consumption path. So therefore it does not count correctly. The solution would be, okay, we just put it out of the consumption path and at the very front near the feed-in point, and then have the correct value ready for SolarWeb. Last but not least, please also make sure to check if all the data sources are online and connected to the PV system. You can use therefore the analysis function on SolarWeb and have all the connected inverters visible. And you can see, for example, that a few of them just produce 88 watts versus the other have a little bit more. So please also make sure that the PV strings are shared equally amongst the whole system. So of course, it's a little bit different in different settings, but please make sure that every inverter has its perfect production, and therefore we of course need to distribute the strings equally so that everyone has a good voltage to work with. So this would be one solution where we can also use SolarWeb for an analysis feature. All right, so that's actually it. We are at the end of our webinar, and before we now head into the question part, where I want to go through your questions that you put in, I quickly want to give you some insights where you can find more information and support as well. First of all, the recording of today's session will be forwarded to you, to your email address in the next few days. So you can rewatch it as many times as you want. And also you will find this online on YouTube in the next few weeks as well. Secondly, on fronius.com, you can find much more information on how to interconnect the two inverters, how you can do the ripple control settings, and so on and so on. And therefore, I've also put in 2 QR codes for the GEN24 and the SnapI if you want to know more or just looking for the instruction manual, for example. All right, so that would be some organizational topics. I now want to open the question part. So we have one question in here. Okay, perfect. I think we already answered this already. It's not really a question, but the question that they put in was if they can have the presentation. Unfortunately, the slides are not available. We cannot send them out, but the recording is. We will send it out, and then you can, of course, reuse it, rewatch it, or resend it to an interested colleague, for example. All right, if you have any more questions to this topic or to Fronius in general, please let us know. David and I will be online for you a few more minutes. I just turn off microphone and camera now. And yeah, want to thank you very much for tuning in today, for staying with me for this topic. I hope it was interesting, and I hope to see you in the next webinar. Then I wish you all the best. Goodbye, guys.